All right. So this is a parallel circuit. Remember, a parallel circuit has many currents, but one voltage, right? And for example, this resistor is connected to 45 volts. This one is also connected to 45 volts, right? This one is also connected to 45 volts. They all are, right? So what we do, the first thing we do is we draw the currents, right? So I'm going to call this current number 1. Goes here, 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 here. Okay, and that current would be 45 divided by 2.1. I'm using Ohm's law. Current is V over R, right? Which is not how it's stated, but that's how I think about it. 45 divided by 2.1 is 20. Wow, a lot of current. Okay, so this guy is 21.428. I'll say 4.3. All right. Now, the next current goes here. Oh dear. Okay. And that current, this is a 5.6 connected to 45 volts, right? So that current is 45 divided by 5.6 is 8.036. Okay. And then finally, our last current is this last branch, right? Now let's see, green. Do we try green? There's no, there is green. Let's try green. Oh, I think we can live with that. Okay, so that one goes like an Etch-a-Sketch. Okay, here we go. Okay, and that guy is 45 divided by 4.1, right? So 45 divided by 4.1. And that is 10.976. 10.976. All right, now let's take a look at the ammeters here, okay? This ammeter right here reads only that green current there, right? So A3 is going to read 10.976 only. Okay. A2 is going to read the red and the blue, right? Okay, so I can't stand this color. Let's try black. Okay, so A2 is going to read this current, right? Which is 8.036. And it's going to read this current, which is 10.976, right? So it's going to be the sum of that, 8.036 plus 10.976. So 8.036 plus 10.976, 19.012. Ta-da. And then this guy, of course, is going to read all three of those currents, right? So the green one is 10.976. The red one is 8.036. And the blue one is our whopping 21.43. So let's add all those up. 21.43 and then 10.976 and 8.036. All of those go through this. So all we do is we just add those up, right? Okay. So 21.43 plus 10.976 plus 8.036, 40.442. All right, and now let's do the least power dissipated by a resistor. Now let me just give you a clue. On these parallel circuits, we know the voltage in this case and the resistance, and our power is voltage squared divided by resistance. So in this case, to get the least power, we're going to use the largest resistor. Okay, so let's go 45 squared divided by the largest, which is 5.6, right? So 45 squared divided by 5.6. And that is 361.6. That's a lot of watts. All right. Now, here's the thing, right? Again, this gets a little tricky because in this case, it was the largest resistor had the least power, right? And the smallest resistor, it's got this whopping current going through it, right? That's going to be the most power, okay? So if you forget on the day you're taking the test which one's the least and which one's the most, just remember that this is your friend, that's your formula. If you can't figure it out from that, then in this case the biggest R gives you the least power and the smallest R gives you the most. Simply find the smallest resistor and the largest resistor. Calculate the power for both. One's going to be less than the other and it will be the least. The lesser it will be the least. Yes? Yeah? Yeah. I'll do some more of these ones.